All right, in exercise 1 through 10, find the indefinite integral. So we have two functions that have really nothing to do with each other as far as derivative. This one cannot be done by substitution because we don't have a function and its derivative in here. We don't, not even a multiple of its derivative. So these two are not related in any way. So we have to come up with something else, and we have integration by parts. With integration by parts, we have u times v minus integral of v du. That's what you need to know. That's what you have to have memorized. Now, normally we'd pick the u to be the polynomial. And the polynomial up there is t squared. The other function is a natural log. So normally, we'd pick u to be the polynomial. But natural log ruins that. We have to pick a function that we can take the derivative of, and the other function we have to take the integral of. Well, we know what the derivative of natural log of t is very quickly. It's 1 over t. But we could find the integral of natural log of t, I suppose, but we don't know it quickly. Go ahead.
I think the radio's on.
Oh, it's still on. Okay. I thought I heard it, and then I thought I didn't hear it, so anyway. You are late.
Sorry, I'm in NHS.
Yeah, sure.
I was too.
Whatever. See? All right. So we got to let u equal natural log of t. And we got to let dv equal t squared dt. Now we've accounted for everything. We've accounted for the natural log. We've accounted for the t squared dt. Well, now we need du. Du equals 1 over t dt. And v is now the integral. So we integrate both sides. 1/3 t to the third. Yeah. Now the integral of our original is u times v, which is 1/3 t to the third natural log of t, minus the integral of v du, which is 1 over t times 1/3 t to the third dt. Well, now we have something that we can take the integral of once we clean it up a little bit, minus 1/3 integral of t squared dt. One of those, that 1 over t cancels out one of the t's, making t squared. Now the final answer is 1/3 t to the third natural log of t minus, now the integral of that is 1/3 t to the third, so we have 1/9 t to the third plus c. Now we took the derivative of that, we get right back to the beginning. Questions? Normally we take u to be the polynomial, but natural log ruins that. We have to switch it. Yeah, it wasn't working either earlier.
It's done.
Did it go? Oh, it did. Well, it did. It picks and chooses, I guess. Solve the initial value problem. I still have students that don't know what this means when they're given a differential equation. It means back up to the original equation. It means take the antiderivative. We separate the variables, dx. And that was on your free response question that we did yesterday or a couple days ago or whatever it was. It said solve the differential equation. I had a couple of students going, what do I do? Well, it means go back to the original function. So we're going to multiply by dx. dy is equal to x plus 2 sine of x dx. So we split the differentials when it says solve the differential equation or solve the initial value problem like here. Initial value problems means they've given you a point to find the c. Well, now we integrate both sides. Left side is y, and then we have the integral of x plus 2 sine of x dx. Now we can let u equal the polynomial. U is equal to x plus 2. This is not natural log. There's no natural log to mess everything up. So dv is sine of x dx. We've taken care of everything. The x plus 2, the sine x dx, everyone's accounted for, and now we do the process. So du is dx, or 1 dx, right? The derivative of x is 1. V is negative cosine of x. Now we follow the pattern. U times v, which is negative x plus 2 cosine of x. There's u times v. And then we do v du. So minus integral of, we got plus, right, because it's minus minus, and then cosine of x dx. Well, now we have something that we can actually take the integral of. We know what the integral of cosine x is, so the answer is x plus 2 cosine of x plus sine of x plus c. Now, if we took the derivative of that, we would get the original. We'd go right back to the beginning. Any questions on this one? So this is a case where we do let u be the polynomial. Oh, all right. I'll back up.
It said like when y equals 2 and x.
Oh, yeah. Thank you. I totally forgot that. Y equals, that's the bad part about this smart board. 2, 0. So I have to point 0, 2. Point 0, 2. Plug 2 in for y. Negative. 0 plus 2 times cosine of 0 plus sine of 0 plus c. 2 is equal to negative 2 times 1, negative 2, plus 0, plus c. So c is equal to 4. Here's our final answer, negative x plus 2. Cosine of x plus sine of x plus 4. There we go. Thank you very much for that help. Thanks, Smartboard. I covered it up, forgot. Yeah.
If you had like cosine squared x plus sine of x, could you change it out for 1 in like a problem like this?
If I had cosine squared, I'd have to change it to 1/2 plus 1/2 cosine 2x.
Okay.
Yep. Use parts to solve for the unknown integral. This one's still integration by parts, but it's different in that we don't have a polynomial. So one of them is not. We don't have a polynomial up there at all. Neither one of these go away if you took the derivative enough. Like if you have a polynomial, let's say x to the third, if you take enough derivatives, it eventually goes to 0. We like that when we're doing integration by parts. That's good. It's a good thing. But we don't have that now. So we have to do integration by parts twice to get back to this, which makes our problem a mile long. But it's still the same process 2 times. So here we go. We're going to let u equal e to the x. We're going to let dv equal cosine of 2x dx. du is equal to ex dx, e to the x dx. And v is 1/2 sine of 2x. That's the integral. So with u, we do the derivative. With dv, we do the integral to back up to v. Now we kind of keep this with it. E to the x cosine of 2x dx is equal to u times v. 1/2 e to the x sine of 2x minus the integral of v du, which is 1/2 e to the x sine of 2x dx. Well, we didn't end up with something that we can take the integral of. As a matter of fact, we made it worse. It was ex cosine of 2x. Now it's 1/2 ex sine of x, sine of 2x. It got worse. But now if I do this one more time, I will get this. So now we're going to let u equal 1/2 e to the x. We're going to let dv equal sine of 2x dx. The derivative is 1/2 e to the x dx. And v is negative 1/2 cosine of 2x. we have the integral of e to the x cosine of 2x dx is equal to 1/2 e to the x sine of 2x minus, so we take all of this comes along, even the minus, and now we're minusing u times v, so that's going to be negative 1/4 e to the x cosine of 2x minus integral of, that's actually going to be plus, right, because it's minus minus 1/4 e to the x cosine of 2x dx. Go ahead.
Where does the other integral one, oh, you split that, never mind.
Okay. This is equal to 1/2 e to the x sine of 2x plus 1/4 e to the x cosine of 2x minus 1/4 integral e to the x cosine 2x dx. So now we got back to the beginning, right there, sitting on the end, with a 1/4, with it. That's okay. To have a multiple of it is perfect, because now we're going to add 1/4 to both sides. We're going to add that over here, plus 1/4. You know it's a long problem when I actually have to take a whole step to get back to the beginning. I actually have to walk back over to the beginning. All right, so 4/4 plus 1/4 is 5/4. So that's gone. That's gone. This is a 5/4. Equals all of that, right? And then we have to multiply by 4/5. So e to the x cosine of 2x, the integral of that is what I'm looking for, is 5/4 times that. So 5/4 times 1/2. 5/2. So 5/2 e to the x sine of 2x plus 5/4 times this. Oh no, wait, no. I multiply by 4/5, right? Multiply by the reciprocal. Try that again. Smaller eraser. Not 5/4. It is 5/4. I'm multiplying by 4/5. Alright, so that makes this 2/5. Plus, ooh, the 4s are going to cancel out. 1/5 e to the x cosine of 2x. There we go. Plus c. So we got to get back to where we started. And multiply by the reciprocal. Questions on that? Go ahead.
Where did the 1/4 come from? In like the parentheses?
1/2 times 1/2. And then the other one comes from, this one comes from negative 1/2 times 1/2. When I did the integration by parts the second time. Go ahead.
So, why would you take the one that's integrated over to the other side and not the one that's not integrated?
So
Because we start with an integration.
okay, so I could say that if this was, let's just call this y, and this one over here is minus 1/4 y. I'm just adding this over and combining and then multiplying by the reciprocal. So what's your question? I guess I don't understand the question.
I don't either.
Okay. Give them a try. If you're not getting it, let me know, and I'll help you out, all right? Maybe you can answer your question that way. Okay. Anything else? Anything else? Oh, yes. Tabular. Tabular is awesome if you have a polynomial. And we do. X to the third. That's good news. We're going to let dx be x to the third. So someone came up with a pattern with this repeated integration by parts. There's a pattern that's going on, and the tabular exposes the pattern. Look, we keep taking the derivative until we get to 0. So you start with the original, keep taking the derivative until you get to 0. If you don't have a polynomial, this doesn't work. The other one, we're going to take the integral of e to the negative 2x. We're going to keep taking the integral until we get down to even with that 0. The integral of e to the negative 2x is negative 1/2 e to the negative 2x. The integral of e to the negative 2x is e to the negative 2x, but then times 1/4 to get that 1/2 when we multiply by negative 2, which is the chain rule. So the integral of e to the negative 2x is e to the negative 2x times negative 1/8. And then finally, e to the negative 2x times 1/16. Now here's the pattern. We draw diagonals from the very first one down to the second one on the other side. And we keep drawing these diagonals right there. This is part of the pattern. And if you did integration by parts enough, if you spent 4 or 5 hours doing it over and over and over again, you'd see this pattern. You would. This starts out with a plus, then a minus, then a plus, and the minus. So you have some extra signs going on because there's a minus in integration by parts. So that's where this extra sign comes from. All right, so now we multiply along the diagonals. X to the third, it's like times 1 times negative 1/2 e to the negative 2x. So the answer is, here we go. We got negative 1/2 x to the third e to the negative 2x. Then this one's going to be a positive times a negative times a positive, which means it's going to be a minus 3/4 x squared e to the negative 2x. Then the next line is a positive times a negative. That's a negative. Minus, and it's 6/8. So 3/4. 3/4 x e to the negative 2x. And then finally, positive times a negative times a positive. It's minus 6/16. 3/8. 3/8 e to the negative 2x plus c. Now, without that tabular method, we would have had to do integration by parts probably 3 or 4 times. I don't know because I haven't really done it 3 or 4 times. I just use tabular. So anyway, that saves lots of time. You just use the pattern. All right, that's it.